Hey, hopefully better late than never is the mantra for page 413 and 421 that y'all had questions on. So 413, number 56, was a tougher one. Bacterial growth. The number of bacteria in a culture is increasing according to the law of exponential growth. So we have the y equals CE to the KT relationship. There are 125 bacteria in the culture after 2 hours. And there are 350 bacteria in the culture after 4 hours. All right, find the initial population. So this one's just a little tougher because usually it starts out with the t equals 0 and some more facts. And then we find out how much is in there later in the experiment. Well, this time we have two snapshots throughout the experiment, and they want to know how did it start. So what we're going to have to do is we're going to take this equation and let's plug in the fact for these facts. So we get 125 equals CE to the 2t, or the KT, the 2K, and plug in this fact and we get 350 equals CE to the 4K. So I have two equations in two variables. This is a system. We're going to solve it together using, I think I'll use elimination. Let's solve this one for C. So this is what C equals. I'm going to take it and plug it in over here. So we're just solving for one variable and plugging it in the other equation so we can solve for the other variable. Let's make that a fraction. When we divide, right here we're dividing like bases. So we're going to subtract their exponents. So that would be e to the 2k. And let's divide both sides by 125. Let me get my calculator. .8. And y'all make fun of me, but I'm addicted to the Schwab, so I'm going to mix it around. So I can do the ln base e of 2.8 is 2k and divide by 2 to get k by itself. So k is approximately ln 2.8 inner divided by 2.515, but I am rounding here, so I don't love that. But now we know what k is approximately. So we can go back to the original. Let's go back to this one. And let's plug in our k value. And I'm just going to get c by itself. So let's divide by e to the 2 times 0.515 on both sides. And we'll be able to figure out what c is. So it's 125 divided by, I'm going to do a parenthesis, e to the 2 times, I'm going to do second answer just so I am being really careful with my rounding. And I got 44.6 for my C value. So now we know C and K. So we're just completely working backwards. So now we'll go to this y equals CE to the KT, and we can plug our C value in and our K value. And this is the equation we're working with. Now we can answer A part. A part said how many bacteria were in the initial population. So initial population means t is 0. So if we plug a 0 in, five 15 times 0 is 0, e to the 0 is 1, so we'd get 44.6 bacteria. Is it in millions? No. So A part is just 44.6. So it was tougher because we had to work backwards and do a lot of algebra. B, write an exponential growth model for the bacterial population. Let T represent the time in numbers. So the exponential growth model for the population is just what we wrote just now, the 44.6 e to the 0.515 t. Whoops. It won't let me write that close to the arrow. 0.515 t. That is our B part. That's our exponential growth model. And C part, use the model to determine the number of bacteria after 8 hours. We would just plug an 8 right there for the T. So 44.6 e to the 0.515 times 8. I got 2,745.5 approximately for my Y. That many bacteria. Okay, now let's look at number 21. They wanted us to find the particular solution that satisfies the general condition. So we're going to separate variables and integrate and then plug in our initial condition. So let's take the dv and multiply it to the other side. Sine of v squared dv. And we need the u over there with the du. So let's divide both sides by u. So du over u equals v sine v squared dv. Now we're ready to integrate both sides. And this is our 1 over u du. So it's the ln of the absolute value of u. And this, we're going to let this be our variable. And I don't want you to get confused with the u on the left side, but if we did a little u substitution, u would be v squared. So then du would be 2v dv. We already have a v dv, so we need a 2 and a 1/2. So we have 1/2 the integral sine u du. So that's 1/2. The integral of sine is negative cosine plus c. So let's get that u substituted real fast to get rid of all these u's that we don't need on the right. So that's cosine of v squared plus c. All right, so we don't want to work too far before we go ahead and substitute. This would be u of v would be 1. So that means v is 0 and u is 1. So we could plug in those values. So let me just take this up here. So that would be the ln of the absolute value of 1 equals negative 1/2 cosine of 0 squared plus c. Ln of 1 is 0. Cosine of 0 squared is the same thing as cosine of 0, and the cosine of 0 is 1. Negative 1/2 times 1 is negative 1/2. Add it to the other side, and we'd get c to be 1/2. So we're going to plug that in right here. So our general solution is ln absolute value of u equals, let's call it negative 1/2 cosine u plus 1/2. And I guess that's how I'll leave it. Let me look. Okay, that's not how they left it. And I just realized when I plugged in my C to this one, I should have plugged it in so that that was V squared. So make that little check for yourself. All right, so we want to give it its base. We're going to solve for U. So we're going to do swoop e to all that stuff on that side is equal to the absolute value of U. This was that little trick we did in class where when you multiply like bases, you add exponents. So this must have separated to this times e to the c. And then e to the c is a constant to a constant, so that's just a c. So let's just write it in the front. And then I believe since c could be positive or negative, we can drop the absolute value bars. And then I think what we have is great because, oh, I forgot to use my, sorry, long day. Well, really, I just forgot. I went to all that work to find what C was right here. Almost erased it. C was a half, but then I just wrote C back here instead of a half. So that's a half, and that's a half, and that's a half. So they left it right here. They didn't do all that solving that I did. Okay, so if I just take this over and I factor a half out of both of these terms in my exponent, I would get this, and they called it negative cosine v squared plus 1 all over 2 for their u. Alrighty. And e is a power. E is raised to a power. Even if that power becomes negative, it won't matter, so we can drop the absolute value bars there. Alrighty. Yeah, that one was a fun one. Now let's look at 39, see what's going on there. Weight gain. A calf that weighs 60 pounds at birth gains weight at the rate dw for dt equals k times 1200 minus w. So at t equals 0, its weight is 60 pounds. All right, let's separate our variables. Let's multiply dt to the other side. And we want the w on the left, so let's divide by 1200 minus w, since that's all grouped together. So that is 1 over 1200 minus w dw equals k dt. And we're ready to integrate. This is our u. So if u is 1200 minus w, then du is negative dw, so we just need a negative. So that's negative absolute value of 1200 minus w. And on this side, we just need a t, so kt plus c. So let's give the base of e. Let's see here. Do I want to divide by the negative? Yeah, let's divide by the negative in front of that log. So it'd be ln base e of 1200 minus w equals negative kt. It's not going to affect the c though, it's a constant, so we'll just leave it positive. All right, so do the swoop. E to the negative kt plus c is equal to absolute value of 1200 minus w. And let's do that little separation thing. So that means e to the negative kt times e to the c is 1200 minus w. E to the c is c, e to the negative kt is 1200 minus w. So I can drop the bars because c can be positive or negative. So c e to the negative kt minus 1200 is negative w. So 1200 minus c e to the negative kt is positive w. So I just did a little switch in the order and change signs there. So that's my weight for equation. And let's see what they want now. 39. Solve the differential equation. Okay, we did. We got the w by itself. B part, use a graphing utility to find the particular solutions. So you would just plug that into y equals, and you would find the particular solutions for k is 0.8, 0.9, and 0.1. Don't we need to know what c is, though? Oh, wait a minute. We haven't used our initial condition. We have an initial condition, so we can figure out what c is. So 1200 minus c e to the negative k times 0 is equal to our 60 weight. So negative c e to the 0 is equal to minus 1200 on both sides. Negative 1140. So divide both sides by the negative. So c is equal to 1140 because e to the 0 is 1. So plug that right here. So that means w is 1200 minus 1140 e to the negative kt. Then you can do b part. You're going to plug this equation into y equals, and then you're going to look on your table and do the, what is it, second ask from table set. Let me look. Second table set and go down to independent and choose ask instead of auto, and put in 0.8, 0.9, and 1 and see what your values are. So that's how you'll do B part. C part, the animal is sold when its weight reaches 800 pounds. Find the time of sale for each of the models in point B. So you'll follow those out on your graph looking for 800 pounds. And which is your Y. And then what's the maximum weight for the animal for each of the models in point B? All right, let's go ahead and do 0.8. Let's do B part all the way out for K equal to 0.8. All right, so I'm not going to do the ask thing actually. I'm going to just do table start for 0.8 and go to my Y equals and enter this in. 1200 minus 1140 e to the negative 0.8x. I don't even need to do that table start thing. Change that. All right, let me show you what I've done so far. All right, so I'm I'm just putting that equation into my calculator. Sorry for the glare. And let's look at the graph. And what's my window set at? Oh, my window's nice. Let's zoom out.